wired up down here in configure. You can see here we have our controllers mapped through, so should be okay. So the way I'm going to test it, I'm using a tool called Insomnia. If you want to use a web browser or you want to use Postman, Postman's obviously very popular, go for it, doesn't really matter. I like Insomnia because the interface is a little bit cleaner. It's just nicer for making videos. So I've got an empty environment here, and you can download Postman free off the internet. I'll put a link down below. I've got an empty environment, so what I'm going to do, because we're going to do a lot of testing throughout this, believe me, we're going to do a lot of testing in a lot of different environments. So I'm going to create a new folder, and I'm just going to call it local dev. So that's a local development environment, and I'm going to put all my requests for local development in here. And then I'm going to create another folder, and I'm going to call it platform service, because we're going to be testing a platform service and a few other things as well. So local dev platform service, and then we're just going to create a request, new request. I'm just going to go get all platforms. You can obviously call this anything you like, it's just a label really, and it's a get request, so create that. And where are we going to get our stuff from? Well, we're going to, if we come back over to our running application, scroll up a little bit, you'll see that our application is listening on localhost 5001 for HTTPS and 5000 for HTTP. Now, in this video, I'm actually not going to work a lot with HTTPS, which is not something I would usually do, but for various reasons, more especially when we come to Kubernetes, it becomes very, very complex, and it's going to kind of detract us from the core of what we're focusing on. So for the most part, I'm going to be hitting the HTTP endpoints rather than HTTPS. Now that's something I might tidy up in future videos, but for the moment, I don't really feel it's too much of an inhibitor, especially not when we come to running things in Kubernetes. But it does come back to haunt us a little bit later on in the video when we come to using gRPC, but we'll cover that off when we come to it. So just wanted to call that out. Yeah, running on localhost 5000, 5001. For the most part in this video, we're going to just be working with HTTP to keep it simple. Otherwise, we start going down some rabbit holes. So let me just copy that, in fact, and I'll just paste that in and put that in over here. And then we want to put our route in, so it's API platforms, okay? So get request, here's our base URL, and then the route to our action, it's API platforms, which should look familiar to you. Now if we come back over here, it's basically what we specified up here at our class level. If I can find it. No, that's looking in the wrong looking startup. In our platforms controller, we come over here to our class. So our class level, this is our class level route, API platforms. And then we've specified a get. And so the method signature that we're calling from Insomnia will match this method signature here. There's no attributes being passed in or anything like that. So we should get a result back. So let's hit send. And indeed we do. So there we go. We get 200 response back, and we get our 3 platforms returned, which should look quite familiar. These are the platforms that were injected into our in-memory database. So that's awesome. We're on the right track. So all we've got to do now is just finish off our last 2 controller actions, and then we're ready to move on to some of the more interesting stuff. All right, cool. So let's come on to finish off our controller. We'll finish it off for this section. We are going to add a lot more into it going through the course, but for now we're going to, yeah, just finish off the basics and get our other 2 action results in place. So if, like me, your server's still running, just Control-C to take that down and get rid of the terminal. Don't need startup for the moment, and we're just going to work exclusively within our platforms controller class now. So what I'm going to do is I'm going to get rid of the sidebar, and I just pressed Control and B just to get rid of that, and you can toggle that on and off. We're not going to be moving around any of our files for this last section. We're just going to be working completely in here, so we can give ourselves a bit more breathing room and see exactly what's going on. So the next action I'm going to add in is going to be very similar to this, but this time we're going to request just one platform using an ID. So let's come on and get on and do that. So again, public action result. What are we returning? Rather than an IEnumerable, we're just returning a single platform. Read TTO. That's all. And I'm just going to call that get platform by ID. And then we are going to expect a parameter this time of type integer, and we're going to pass in an ID. Now, when I was talking about this API controller giving us some out-the-box behaviors, this is kind of what I'm talking about here. By defining this ID as part of an input parameter to this action result, basically that will be interpreted automatically when we come over to testing it, and we pass in /2 to relate to one of the IDs of the platforms. That this route will basically be automatically interpreted by this to map to that. Okay, it's kind of nice. You can explicitly tell what you're mapping through from your request, but in this instance, it's all doing this kind of stuff out the box for us. But of course, we do have to specify that it's a HTTP GET. Okay, and then it's actually very similar to this here. So the first thing we're going to do is declare a variable to hold our results. I'm going to call it platform item, singular this time, because we're just looking for an individual item. And again, we'll make use of our repository class, and we did create a method in here called getPlatformsById. Fantastic. And what do we want to pass into it? We want to pass into the value that's been passed in through our URL. Okay, so we're going to attempt to get whatever was passed in. Now, as per sort of REST best practices, if you try to locate a resource, an individual resource, as we're trying to do here, and it's not found, you should return a 404 not found HTTP result set back. Okay. So that's what we're going to do next, or that's the kind of the check we're going to make. So if platform item doesn't equal null, then we have something, that's good, and we're going to return it back. So we'll return it back with an OK. And we're going to do something very, very similar as we did up here. In fact, almost identical. We just don't need to specify that it's enumeration. But let's type out anyway, because it's good practice to get across this stuff, because we're going to use AutoMapper quite a lot. So mapper, map, what we're mapping to. Instead of an enumeration of platform read details, we're just mapping to a singular platform read detail. And what's our source? It's this platform item. And that's it. Nice and straightforward. So if the platform item returned is not null, great, we do that. Otherwise, we're going to return not found result. And that will return a HTTP 404 for us. Fantastic, so let's save that off, bring up our command line, let's do a .NET run. And remember, doing a .NET run also does a build for us as well, as you can see there. But I don't know why, I sometimes still like to run a separate build and then do a run. I don't know why, it's just my weird way of thinking. So let's run this one again, let's take out the 2 and just make sure it's still working. There's no reason why it wouldn't be. Well, it isn't working. What have we done wrong? You've done something wrong here. Let's find out what we've done wrong. And we'll just scroll down a little bit. The request match multiple endpoints. Oh, I know what I've done wrong. So this is actually a really good example of something that we forgot. Well, I forgot to put in. You can see here we've got 2 HTTP GET requests, and it actually wasn't intelligent enough to, I forgot a really important thing. We actually have to specify an additional route in here, because otherwise what that error is saying is we've got 2 HTTP GET requests, which it interprets as being completely identical. It doesn't even get down to the method signature here, even though the method signatures are different. So bit of an omission there. So let me just rectify that. So within our HTTP decoration, let me just do open brackets. And what we're basically doing is we're specifying effectively a route, part of the route that we're looking for. So the way you do that is string, double quotes, curly brackets, ID. So we're saying we are expecting, as part of this GET request, an ID. And as part of that, that is then mapped into this. Yeah, that's my bad. You really forgot to mention that. So yeah, as part of this route here, if we do this, 23 for example, it's going to match this route here. If we take this out, then it's going to match this route here. And it was getting confused because we had no point of differentiation. And where API controller comes in is it automatically maps this value into here. There you go. Early in the morning for me here, I'm not quite woken up yet. Now, the other thing we're actually going to do while we're doing this, I'm actually going to give this a name, and you'll see how this comes into play in the next short while. And I'm just going to give it exactly the same name as the method signature name. Okay, and we actually make use of this a bit later on in our next action result. Okay, Cool, there we go. So that should be okay now. So let me run that up again. Control C and run it up again. And let's see how we're going. So let's come back to Insomnia and let's just run our old request. There we go, back to normal. That's cool. And then we're going to create a new request explicitly for get a individual platform. Okay, there we go. And what I might do is I might just copy this over and I'm going to paste that in here. And let's have a look at our result set over here. So you can see the in-memory database has automatically added IDs for us. Fantastic. So let's see if we can pull back Kubernetes, since we're going to be working with that next, and put in 3. And indeed it does, it pulls back the individual platform for us, which is all good. Now if we put in some ID that doesn't exist, we'll get a 404 not found, which is exactly what we want, and that kind of adheres to our REST kind of standard practices. Fantastic. Okay, good. So I'm actually quite glad I had that error, honestly I am, because it kind of helps you understand how things work. And that's a really, really good point. When you make mistakes and when things don't work, that is actually, for me personally, that's when I learn stuff. If everything just goes totally smoothly all the way through, you're going to learn stuff, but not as much as when things go wrong. Okay, so this is a long course. I'm just going to call this out here. This is a long video. You're going to make mistakes. I guarantee it. I guarantee you're going to make typos here. You're going to forget to put things in there and things are not going to work. Don't stress out about that. The code is available on GitHub and you can, if you want to, you can just kind of overlay that on what you're doing. But what I would suggest you do is try and fix it, because in trying to fix it, you're going to learn a lot more than just listening to me talking and going through the video. All right. So rant over. We're going to move on to our last action result, which is creating a platform using our controller. And then we're going to move on to a bit of Docker and then Kubernetes. All right, so let's come on to creating our third and final controller action in our platforms controller. And it's this controller that we're going to use to create platforms in our backend database. And it's this controller that's going to be the one that we're going to return to and do a lot more work in terms of triggering messaging to other services. So we're not done with this one fully yet, but we're going to get it into a state where we're creating platforms and then we're going to move on to something else, but we will return. So before we do that, let's just do a Control C to kill the running server, get rid of this, and then we'll move down and we'll create our final action. So again, public action result. And what we're going to return back, we're actually going to return back a platform read DTO. So when you create a platform using the service, part of the REST spec is that you should pass back that resource once it's been created. And so anytime, again, without sounding like a cracked record here, anytime you're returning data back, we're going to use the read DTO. So there we go. Platform read DTO is what we're returning back. We're going to call this method create platform. And what we're going to expect as an input, any ideas? We're going to expect a platform create DTO. There we go. And we'll call it platform. I'll tab that through. So just to go over that again, we're going to return back a platform read DTO, assuming we create one. And what we're passing in, we're passing in a platform create DTO, and that's the DTO we created explicitly for creating platforms. And the only difference really between these two at this point in time is the create DTO doesn't have an ID because our database creates that for us. All right, fantastic. So let me just do our curly brackets and let's make sure this time we specify the correct, we decorate this with the correct route. So it's going to be a HTTP post this time. And that is all we need to do actually in this occasion, because when we are creating or posting a new platform, we don't actually have to specify an ID. If we were doing an update or something, we would have to do something very similar like we did up here and actually specify that we're expecting like a resource ID in here. But for creating, we're just saying it's a post request. And looking across our entire controller, all of our method signatures are now unique. So this is just a HTTP get, this is a HTTP get with an ID, and this is a HTTP post. So the first thing I want to do is actually make use of AutoMapper. So we're getting passed in a platform create DTO, but our repository works with models, it doesn't work with DTOs. So we're going to have to map our create DTO to a temporary model object that we'll then use to pass into a repository. So let's do that first. So new variable, I'm going to call it platform model, and that's going to be equal to mapper, map. And what are we mapping to? We're mapping to a platform object, a platform class really, not an object. Okay, I'll bring in the namespace for that because I don't think we have that yet, using platform services models, okay. And what are we mapping from? What's our source of our data? Well, it's this here, it's our platform create DTO that was passed in. I'll just put that in here, okay. And we'll round that off with a semicolon. And again, coming back to our API controller decoration here, you're going to probably ask, where is this coming from? Well, we're ultimately, when we come to testing it, we're going to place it in the body of our request. And again, by using this API controller decoration attribute here, this action will kind of look initially to the body request of the request that comes in, and it will just put whatever object it has into here by default. Now you can override that with more explicit behaviors, but again, the default behavior is fine for our purposes. Okay, so we've got a platform model now, hopefully, if our mapper has worked correctly. And if I just do a Control B to bring up my directory listing here and come back into our profiles, you'll see that this is the mapping that's kicking into play. We're taking a platform create DTO as the source, which makes sense, and we're mapping it to a platform. All right, so we're making use of that second automapper mapping here. And then it's quite simple actually. We then make use of our repository and we will do a create platform. And what does that expect? It expects a model. And so we're going to pass in platform model like so. Fantastic. Now, one thing that we obviously always need to do whenever you make a change or anything like that, we'll need to go back to our repository and we'll need to save changes as well. If you don't do that, if you leave that out, you will have nothing created in the database. So now what we want to do is we want to pass back our successful result if we have one. So in this case, a platform read DTO. As per REST kind of best practices, whenever you create a resource, you should return a HTTP 201 along with the resource that was created and also a URI to that resource, a location to that resource as well. So we're going to do all that in the next few lines of code. But the first thing we need to do then is we need to somehow get a platform read DTO. And so what we're going to do is we're going to use automapper once again, and we're going to map from our model that we've just created back to a read DTO. Okay, so we'll do var platform read DTO equals underscore mapper. What are we mapping to? Oh, we've got map, and what we're mapping to? We're mapping to a platform read DTO. Make sure you get these right. I've got these wrong on occasions and mapped to the wrong objects, and it's caused me some problems down the line, but there you go. That's all part of learning. So that's what we're mapping to. What are we mapping from? We're going to map from platform model. Okay. Just get rid of that space there. Okay, so platform create came in, we mapped it to a model, we put our model into our database, and now we're going to return back the platform read DTO version of that. Now this might all seem a little bit long-winded to you. I've had some feedback, people saying they don't like this kind of decoupling to this extent. Well, that's okay. Personally, I still think this is absolutely the right way you should be doing this, okay? You shouldn't be passing back models directly over the wire. I definitely don't think you should be doing that. So what we want to do next then is we've got a platform read DTO, we want to return it back with a HTTP 201 to our requester. Now this line of code coming up is probably the one that I get the most comments about, going, this doesn't make sense, and it's a little bit convoluted, and the Microsoft documentation isn't that great. So I'm going to type it out, and then I'm going to go through and try and explain it, what it's actually doing. It's not really that complicated, but it's a little bit convoluted, and it's not really that intuitive, to be honest with you. Anyway, let's get going. So we're going to return, and we're going to use something called created at route. And so what this effectively does, it returns us to HTTP 201 with a route as part of that return. So the first parameter that we're going to pass in is actually the name of basically the route where we can get to our resource. So name of, open brackets, and where is this resource residing? How do we get to that resource? Well, that is why up here we gave this action a name, because this basically is the resource URI. Whenever we create this resource, you can actually then get to it using this action result. So we're going to supply this name, okay, to this here. So this is basically, this first bit is saying this is the route where you can actually then get this created resource, okay? And then we're going to actually basically return back the resource itself. And this is, again, this is something to get rid of this Control B to get rid of that and give us a bit more room. Again, this is a little bit kind of not that nice really, but let me just type it out anyway. So new, curly brackets, ID equals platform read DTO, ID, so this is getting our ID, and then we're actually returning back the platform read DTO as well. And I think I've spelled that wrong, there we go. All right. So basically, we're going to return a 201, we're going to give the route, which is basically this thing here, and then we're effectively generating a new ID, which is basically the resource ID, and then we're passing back the body payload in the response as well. All right, so let's save that off. I think that's all looking okay. Let's do a control backtick. Let's do a .NET run to run that up. And let's wait, that looks okay. And let's come back over to Insomnia, and I'm going to create another request, new request, and this time it's a post request. And we're going to be expecting some JSON as the body. We're going to pass in a create DTO JSON payload, and we'll call that create platform. Fantastic. Now the URI is actually going to be exactly the same as this. Different verb, but same URI, so let's just put that in here. But we are going to supply a JSON body. Now what I'm going to do is I'm going to come over to, let's pick this one here. No, let's pick this one here because I want to get an example payload, and I'm just going to copy one object, okay, just so we have, you know, we don't have to bother typing it out, and we have the correct format. So I'm copying one object, curly braces to curly braces, and I'm going to paste that in here. Now, let's come back, before I do anything with that, let's come back and do a Control B. Can I do a Control B if we've got the thing running? We can. And we come back to our DTOs, and let's just take a quick look at our platform create DTO. So what we're expecting to get passed in here is a name, a publisher, and a cost, okay? No ID. So come back over here and back into Insomnia, we'll take this out. Okay, we don't need that as part of our create payload. There's no ID in here obviously because we don't have one yet, but we do need these three attributes here. So let's create a new platform. Let's create Docker because we're going to be moving on to that next. Who publishes Docker? I'm just going to put Docker. I think that's probably right, might not be that, and the cost is free. So let's send that over. And there we go. We get a 201 created, and we get our resource passed back, and you can see we've got a new ID of 4. If you look over our headers, most importantly, you can see we have a location, and actually it is the URI that we can use to retrieve that resource. And again, that's a really important part of the REST specification, and that was achieved by using, let me come back over to our controller, using this created at route methodology here. Okay, that's what that really gives you. Although it's a bit of a not particularly nice construct, that's what that is basically doing. So that is all looking pretty good. The last thing I'm going to do is actually copy this URI just to check it, and I'm going to paste it into here, into our individual platform. Just check that it works. There we go. 200 okay, and it's returned the right thing. And finally, if we just retrieve all our platforms now, you'll see that we have Docker in there now. Fantastic. So that's basically just a fairly standard, straightforward .NET Core web. I have to stop saying core .NET Web API now, but it's going to form the basis of our platform service going forward, and we're going to add a lot more interesting stuff into it. Cool, so we'll park that there for now, and the next thing we're going to move on to is a bit of a review of Docker. We're going to Dockerize this, run it in a container, before then moving on to possibly the main event, which is getting all this into Kubernetes. All right, so time for a quick review of Docker. Now, we cover everything that you need to know about Docker in this video, but if you want a bit more detail, maybe check out one of my other videos. But let's take a look and do a quick review. So what is Docker? Well, as it says on screen, Docker is a containerization platform, meaning that it enables you to package your applications, in our case, our platform service, into something called an image, and then run those images as containers on any platform that can run Docker. So what does that mean? Well, basically what Docker allows you to do many things, but one of the problems it helps you solve is this idea that you might be running something you develop on your machine and it works brilliant, but then when you come to deploy it onto some other environment, it doesn't work and there's missing dependencies and all that kind of stuff. So what Docker does is it kind of removes that problem by allowing you to package something using Docker into an image. And once you have that image, you can be fairly sure that you can take that image and place it onto anything else that's running Docker and run that image up as a container, and you can be fairly sure it's going to work okay. So it allows for this kind of transferability and this easy deployability of applications, okay? And it's really referred to, or really could be thought of, as application virtualization, which is a nice segue onto the next slide. So what I want to do here is just call out the differences between running a plain old server or PC, running an operating system and running applications, versus virtual machines versus containers. All right, so in the first instance, you've got a PC or a server, it's running an operating system, it's a physical machine, and you just run your applications on that operating system. Fairly straightforward. We then have a virtual machine setup, which is basically operating system virtualization. And in this case, you'll have your host operating system. You'll then have some kind of hypervisor, which will then allow you to run entire virtual machines on that hypervisor, which then have an entire operating system all of their own. So in days gone by, I've run things like VMware or VirtualBox to run a Linux virtual machine on top of my Windows host system. Okay, now that's a perfectly acceptable use case, and virtual machines are still very much used today. Where Docker comes into play, and again, this is a very simplified diagram. There's actually more going on here, and there are actually virtual machines involved, but I've taken that away because it was going to complicate the point I'm trying to make. With Docker, or with any containerization platform for that matter, you have your host operating system, you have, in this case, Docker, and then you have your containers running on top of Docker as applications. There's no full operating system involved. Each of these containers has their own view of the host operating system. They don't run on an entire dedicated OS of their own, so they're much more lightweight and much more efficient. But you still get a lot of the benefits with virtual machines in that one of your containers can crash and die or do something terrible. Your other containers are unaffected, okay? So quite a very nice concept and platform, and very much one that lends itself very well to microservices. So I'm sure you're probably starting to think about, okay, you're running up lots of services. It's probably analogous in some way to a running container. And then you can do all sorts of things like scale out your containers horizontally, so you can have multiple instances of the same application running as multiple containers to allow you to deal with extra demand and all that kind of stuff. And we'll do this a bit later. But for now, we're just focusing on plain old Docker. So that's all great and everything, but how do we get our platform service running as Docker? Well, let me take you through that. So the first thing, and the next thing we're actually going to do, is write a Docker file. And that's really just a set of instructions that tells Docker how to take our application, in this case our platform service, and turn it into an image. And again, remember, an image is one of those things that you can distribute somewhere into anything that's running Docker and allow you to run it as a container. So we get a Docker file, along with an application, we run it through the Docker engine, and we end up with an image. Okay, so we're going to do that next. We're going to write a Docker file, we're going to build and create an image, and then we're going to run up our image as a container, and then finally we're going to push our image up to Docker Hub, because we're going to be making use of Docker Hub a bit later on, but we're going to do all that next. All right, so let's get going and start with our Docker file. So just come over back into our project. Now, if you have anything running in your terminal, just make sure you shut it down before we get going. So in the root of our project, just right click, new file, and we'll call it Docker file. No need for an extension, and you can see by the wee blue whale that VS Code recognises what it is. So I'm just going to get going and start building up a file. It's actually quite simple, and if you come over to Google and you just type in something like .NET Docker, this first article here, I'm basically just following this, Dockerizing the ASP.NET Core application in Docker, and there's a Docker file down here, which by and large, we're really just going to be following that, to be honest with you. Making some slight changes, but basically that's it. So the first thing we're going to specify is the image that we want to pull down from Docker Hub that we'll use to start our build. So the image is mcr.microsoft.com/.net/SDK. So we want the SDK image, which is a kind of larger image than just the runtime image, which we'll also be making use of. And I'll just sort of specify the build environment name as build environment. And I'm just going to copy this, and I'm just going to push it into Google, and you can see where on Docker Hub that is hosted. So we just go to Google and paste in the image name. I think that should be sufficient. You'll see on Docker Hub that we have the .NET 5 SDK image, and with over 1 billion downloads, so it's been used by quite a few people. Now, if I just come back over to the main landing page for Docker Hub for my area on Docker Hub, you'll see I've got a few images myself that I've pushed up and hosted on Docker Hub. Now, we're going to be pushing up our platform service here, we're going to be pushing up our commands service here as well. It's part of the whole workflow that we're going to be following. So if you haven't done so already, please sign up for a Docker Hub account. I won't tell you how to do that, it's fairly straightforward, but you will definitely need to do that if you want to continue to follow along. But for now, let's get back to our Docker file. And I'm just going to set my working directory. So workdir/app. And then what we're going to do is we're going to copy over the csproj file so that we know what dependencies we actually need to work with in order to build our image. So copy everything from csproj and copy it to our kind of working directory. Okay. And then we want to copy everything else and build it. We copy from source, copy it to our destination, and then we just want to run .NET publish C release. Got that wrong. There we go. Out. And then we want to build our runtime image. So what we're doing here is we are pulling down the .NET SDK image, which we're using to build the main part of our application, but then we want to actually make the image a bit smaller, and this is what I'm talking about when I've said multi-part build. We're now going to pull down the runtime image and finalize our build and just use that to package up our application. We don't need all the SDK stuff as part of our image. So very similar kind of syntax from mcr.microsoft.com against .NET. And this time the image is ASP.NET :5.0. Specify the working directory app. And then we want to copy the output from our build environment from equals build env to app out. And don't forget the trailing period. Get rid of that. Get rid of that. And then we set the entry point. Now this is when our image is run, what actually kicks off, or what do we want to run basically. And so this is where we specify that. So entry point, say .NET, which is what we want to run, and then we actually specify the name of the DLL that we want. In this case, it's platform service.dll. And that should be it. Let me just double check this over. I think that all looks right. So again, just to reiterate, this is the first image we're pulling down, the SDK image. We're creating a working directory. We're copying over the csproj file. Oh, I've forgotten a line in here. We want to run .NET restore to basically pull down the packages contained in here that we need to build our image. So this is really important. So yes, copy those over, run .NET restore. I don't know why I missed that. We then copy those files over, we then run .NET publish. We then want to build our runtime, our full runtime version without all the SDK gubbins. So we pull down the runtime image, create a working directory, and then we copy the contents of what we built over to that. And then we set the entry point for our image. So when we run our image, that's what gets kicked off. So if you actually come over to the bin directory, you'll see that we have a platform service DLL in there. It's just this thing here, okay, that gets run. All right, so that should be it for our Docker file. Again, if you want more information on this, I've kind of skipped through it quite quickly. Watch one of my other videos. We don't really need to revisit this now, that's it. And we're going to be doing a very similar one for the platform service, but it's literally going to look identical aside from the name of the DLL that we're going to run. So I'll probably just copy and paste it when we come to that point. But that's all we're really going to do with our Docker file. So next we're going to build our image, and you'll see how that works. We're going to run our image. We're then going to stop the running container, and we're going to push something up to Docker Hub. So we'll do all that in the next sections that follow. All right, so we're going to build our image. Now, before we build our image, it's very important that you actually have Docker running. So what I might do is just bring up a command line, come over here, clear the screen, clear the screen. And if you just type not .NET, I'm going to do that quite frequently, docker -- version, you should see that you have some version of Docker running. Now, I'm running Docker Desktop, so the app is over here. So if we just bring this over onto the screen, let me just make that a bit more manageable so you can see it. Oh my goodness, there we go, that's a bit better. So you can see down here, this is Docker Desktop on Windows. You can see Docker is running down in the bottom left-hand corner. Docker's running, and also Kubernetes is running. So if you go into settings, the cog up here, you'll see a number of options, one for Docker Engine, all that kind of stuff. But Kubernetes, make sure you have that ticked. And that will actually make sure that Kubernetes is running by default from memory. It's a long time since I've done it, since I've downloaded Docker Desktop. Kubernetes is not enabled by default. So make sure you enable that and that you see the little whale and the little ship's steering wheel for Kubernetes. So yeah, that's all running. All right, fantastic. So make sure you get that same response whenever you type in Docker at a command line. And yeah, we'll cover Kubernetes a little bit later, but we're just focusing on Docker for now. So what we want to do now is build our platform image. And as I said at the start of the video, I do have a cheat sheet that accompanies this video. You can go to my blog and register there to get a copy of the cheat sheet. So all these commands are in that cheat sheet. So building an image. So making sure that Docker is running, it is. So building an image, it's Docker build. And then we want to tag the build, tag the image with a name basically. And the name that you give it is the name, your username, your Docker Hub username. So mine is binary thistle, and then the name of your service. And I'm going to call it platform service. And from memory, if you put capitalization in here, it won't like it. So make sure everything is lowercase, so platform service. And then the most important thing, now you can specify a version if you want. We're not going to do that. We're just going to not specify a version. And if you don't, then it just tags it as latest, okay? Which is what we want. Most important thing that you'll probably always forget is make sure you put the build context, which is just the dot at the end of that command, okay? You'll probably always forget to do that. I do many, many times. So again, Docker build, and we're going to tag the image with a name, and in this case we want to give it the name platform service, but the syntax you use is the Docker Hub username. And the reason for that is when we push it up to Docker Hub needs to know which account it pushes that image into. So your name here is not going to be binary thistle, that's my name. You're going to have to put your name in, all right? So that all looks good. We just hit run. You'll see what happens. Basically, Docker just runs through the Docker file, and it starts executing all the steps, as you can kind of see here. Now, I think I probably have those images locally on my machine, the Microsoft SDK images on my machine. If I didn't, then it would actually go to Docker Hub and pull down a copy of that. So it might take a bit longer. In your case, if you've not done this before, it might take a bit longer to run. It's probably going to be relatively quick for me because I have those images. Now, one thing it will check to see that it's got the latest version of those images. So even in my case, it might download a new copy of the SDK image if the one I have is out of date. But that all looked pretty good. It looked like it built that all right. Now, one thing I will draw your attention to that I use all the time is this Docker plugin for VS Code. So you can go to your extensions and just type in Docker, and it's probably going to be the first one that comes up. I think it's this one here. Yeah, I've got it installed. You can see, you know, it's pretty well used, get high ratings. I really recommend it. So if you're using VS Code, strongly recommend you install that because you can kind of look at your images and stuff like that. So if we come over here and look at our images, and I'll just maybe refresh those, you can see here, there we go. I have this platform service image, binary thistle platform service image with the version latest. Okay, so that's all looking good. So that's building an image, pretty straightforward. So what we're going to do next is run this image up and see what we get. All right, so we've built an image. We have that available, as you can see here again, and we want to run our image as a container. All right, so let me just clear down our Docker file, and I'll come in here and just clear the screen as well. All right, so to run up our image as a container, the command you're after is docker run, and then you don't need to supply this next bit, but I'm going to supply it because if you don't supply this next bit, there's no way of us accessing the server running inside the container. If you run up a container without this, what's called a port mapping, you can't get into it. So what we're doing now is specifying an external port, a port that we're going to use in our Insomnia session to get into our container. It can be anything, as long as it's not running on your machine, and then the internal port that we're going into. Now, there's an awful lot of this port mapping type stuff that we're going to do, not just in Docker, but more especially in Kubernetes. So there's quite a lot of sort of networking-y stuff in here, which might surprise you, but probably shouldn't when you think about the nature of a distributed application. Anyway, digress for the moment. So we're running up our image as a container. So docker run -p for the port mapping, 8080, I'm using that in my case, to 80, which you will need to use. And then we're going to run it in what's called a detached mode. Now, if you don't have to specify this D flag. If you don't, then basically the container output will be displayed in this command line and in this terminal, and you won't be able to use this terminal to type at. I want to retrieve it back and run a few more commands, but it's quite useful sometimes not to run it with the detached flag, and you can actually see some messaging flying through, such as errors or what startup stuff you're getting. But we're going to run it as detached, and then simply it's just the name of your image, and this can be any valid image name. Obviously, in our case, it's platform service. And in your case, yes, it won't be binary thistle, it'll be whatever your Docker ID is, and in my case, it's obviously binary thistle platform service. And that's it. So again, if you are maybe wanting to pull down a SQL Server image, you could specify the SQL Server image here and run it up and do all sorts of stuff. You'd probably need a slightly different port mapping, but nonetheless, it's the same idea. Docker just goes to Docker Hub and pulls down that image. As we have this locally, Docker Hub in this case will not do that. Hit enter, and what you can see up here straight away, if you're using this plugin, you can see that we now have a container that is running, as denoted by this little green play sign, and we get a kind of ID of the container. So a couple other useful commands for you. Docker PS will show you the running containers, and basically we already have one running here, but if you're not using this, you can use the Docker PS command to see what running containers you have, and you'll have this container ID, which is this thing here, which we can reference, copy that, and issue a Docker stop. Give it the container name, container ID, and you'll see that up here, yes, it's been stopped, and if we do a Docker PS again, we have no running containers. Okay, so that's stopping and starting a container. Now, if we do Docker run one more time, what do you think is going to happen? Do you think this is going to run up? Well, let's give it a go. No, that doesn't happen. What happens basically is you're telling Docker to run this image. So it's going to this image again, and it's running up another container. It's not restarting the same container that you had last time. So just be aware of that. Every time you run Docker run, it's basically running up a container. Okay, and again, Docker PS. To get our running containers, it's got a different ID this time. Let's copy that, and let's do a Docker stop. Paste that in, and you'll see that that too has stopped. So what if we just want to restart the same container? Well, that is then docker start. Okay, and then we actually give it the name of the container or the ID of the container that we want to restart. So if we do that, you'll see that the same container restarted. We didn't get another one. Okay, so docker run to go to an image, run it up. If you keep running that command, it will run up new containers every time. Docker stop to stop it. Docker ps to get a list of running containers, and then docker start with the container ID to restart an existing container. And that's, other than one other command, which we'll cover in a bit, that is the only, they are the only commands that you really need to work with. Or you can just use this, this interface here. So you can right click here, for example, and stop it if you want to do that. Okay, so I did mention there is one other command, and it's one command that we're going to be using an awful lot. More than docker run and docker stop, we're going to be using this command, docker push, along with docker build a hell of a lot, a heck of a lot throughout the rest of this course. So let's go and do a docker push, and then we're just about ready to move on to Kubernetes. All right, docker push. Now, to be honest with you, the command is incredibly simple. There's not really much to it, but what I'm going to do is I'm just going to bring over my Docker Hub page again. Let's come over here. So this is logged into Docker Hub as Binary Thistle, and you can see I have a few images up here already for other projects, but there is nothing in here that says platform service. That does not exist here at the moment, okay? So we'll pull that back over, and back over in our command line, and let me actually just clear the screen, and we're going to docker. Any guesses what the command's going to be? That's right, docker push, and then it's just the name of our image, binary thistle, and again in your case it's going to be your Docker ID platform service. Platform service, cool. And you can see one of the things it's saying, it's using the default tag latest, which is exactly what we want, and then it's just going to start pushing this container up to Docker Hub. So it depends how fast your upload speeds are on your internet connection. Mine used to be really, really fast, but for some reason it's got really kind of quite bad now, so it takes quite a while. So I'll probably cut the video because I'm sure you don't want to watch me uploading an image, but that's it. It just uploads the image. Now, Docker's quite clever in that images are built up in what are called layers, okay? And so if you, this is going to take a while because we've not uploaded it before, but if I upload it again and I've only made some minor changes, you'll usually see that the upload will be a lot quicker because it's not going to upload everything again. It's only going to upload what's called the affected layer. So it's a lot more efficient. But as this is the first time we're doing it, it's going to take quite a while. So what I might do is I might chop the video here and I'll come back. Won't touch anything else. I'll come back once it's uploaded. But basically, that's pretty much it. But we'll wait for it to be uploaded. We'll check Docker Hub and then we'll move on to Kubernetes. Fantastic, so that looks like that's pushed up now. If we come back over to Docker Hub and if I refresh the page, we should see Binary Thistle Platform Service up there, and we just click on it. Yeah, you can see that we have the latest build up there. We've not really versioned it. Cool, so that's push complete. We're going to be using that an awful lot as we move throughout the rest of the video. But next, there was one thing I actually forgot to do, which was actually when we ran our container, take a look at the container running to make sure that we can get to it using that port mapping. So we'll do that next, just before we move on to Kubernetes, just to show you that that's all working. So we'll do that, yeah, do that now. All right, so back over here, let's just run up our, let's start one of our containers that we already had. Fantastic, and if you do a docker ps, see you're running, oh, not PSA, PS. Yeah, you can see it's running and you can see we have this port mapping. So let's come over to Insomnia again. And we've got that here. So we can see we've got our local development environment, the platform service. I am going to create another folder, top level folder. I'm going to call it, although it's technically our local environment, I'm going to call it our Docker environment. And I'm going to create another folder in here. We're probably not going to make too much use of this, but we'll keep it segregated because we might flip back and forward between them, platform service. And then I'm going to create a new request. I'm just going to call it get all platforms. Just a get request. create that. Now what I might do is come over here. I'm just going to duplicate that. Yep, and I'm just going to, no, actually, so we can delete that then. Delete. Yep, click to confirm, and just move that into here. Now obviously, we click on this, it's using localhost 5000. We don't want that, we want to use 8080. All right, and let's see what we get. There we go. So that's how we are getting to our Dockerized image, rather than directly on, directly when we were running it as .NET Run. Okay, so these are the two differences between the two. And actually, as we move through the video, we're going to have other ways of, because eventually this container is going to be running in Kubernetes, so we're not going to access it in this way either. We're going to access it in two different ways, actually. So it all gets not complex, but yes, it's quite complex. It can get quite confusing. So that's why I'm being really careful to segregate which environments I'm running where, because it can get a little bit convoluted. Let's say that. But yeah, anyway, that's it. The container's running. We can get to it in that way. Now, just before we move on then, what I will do is I'll just stop this container with a docker stop. I think that's the same one, isn't it? There we go. Stop. All right, great. So that's a bit of a review of Docker, a bit of a crash course on Docker. I think that's enough to get us going. Docker file and some core commands. We're good to go. We'll be using Docker build a lot, and we'll be using Docker push a lot. But now it's time to move on and take a look at what Kubernetes is. All right, so let's move on to talking about Kubernetes. Now, the reason I've got an onion on screen there is not because Kubernetes makes you cry, although it can get quite frustrating from time to time. It's because, well, the way I think about it is very much like the layers of an onion. There's lots of layers involved in Kubernetes. And when I was first learning it, that's kind of how I envisaged it. So, massive subject area, but what is it in a nutshell? Basically, as you saw in the last section, we were running up multiple containers using Docker Desktop to do that. That's obviously fine for development purposes, but when you're moving into a microservices architecture and you're wanting to kind of make sure your containers continue to run, and if they crash that they get restarted, or that you want to scale them out, clearly you're not going to be running around at a command line doing that. So that's where something like Kubernetes comes in. Kubernetes is a container orchestrator, and you know, it's a good name, and the analogy I think fits really well. The Kubernetes is like the conductor of an orchestra, and it makes sure everything is running as it should, running to time, if you want to put it like that. And again, yes, responsible for making sure things run in the right way, scale out in the right way, all that kind of stuff. And we're going to be working a lot with Kubernetes in this section and the sections going forward, and we're going to tell it how we want it to run things, I guess. So we're going to give it like an end state, an end state that we want it to get to, and Kubernetes will figure out a way of doing that for us. It's pretty cool, actually. Huge subject area. And actually, one of the things I was thinking about when I was making this video was, do we use Kubernetes? Because it can be quite tough. It can be quite a difficult subject area. And I did think about using something like Docker Compose. Docker Compose is, I kind of like to think of it as a kind of a middle ground between Docker and Kubernetes. Docker Compose kind of almost sits in the middle. It allows you to run up multiple containers and network them together. And it's actually a very nice option in, you know, development type environments. But production-wise, Kubernetes is really the option that you would be going for. If you're interested in Docker Desktop, not Docker Desktop, if you're interested in Docker Compose, I've done a couple of videos on Docker Compose to see how that all works. But Kubernetes, it's the main event, and that's what we're going to be using in today's video. So just a little bit more about Kubernetes. I think really the best way of understanding